Alright, hello everybody. This is our series and sequence unit. We're on video 6. It is our third video for geometric sequences, and we're going to be working on sums for this video. Alright, so in this video we're going to be talking about partial sums, which we also did with our arithmetic, but we are also going to be able to talk about infinite sums, meaning we're going to be summing every term in the sequence. And for this we're going to be talking about end behavior. It's really going to help us, and you're going to find a quick way to do that and decide whether or not it's going to work for us. So, and we'll also be doing some working backwards problems together. So make sure you have your graphing calculator ready to go, and we're going to get started now. Alright, so here is our formula for our partial sum, and n is representing the number of terms that we're going to be adding together. A1 is still our first term, and r is our common ratio. So all of these values are familiar to you, and we're going to be finding the sum of the first 8 terms for this sequence. So make sure you've got this written down. If you need to pause before I keep going, that's great. And that is the formula you're going to be using for partial sums. There's only one formula for partial sums. There's not 2 options like there was for arithmetic. Alright, let's go ahead then. So I'm going to find S sub 8 because I wanted the first 8 terms. And I'm going to start with my first, which is 5. I need to find my common ratio, and to do that I'm going to divide the second by the first, so I get a common ratio of 8. So this is going to be 1 minus 8 to the, it just happens to be 8th power, all over 1 minus 8. It's very important that you type this into your calculator very carefully. I would honestly recommend doing the numerator first, then divide it by -7, and then multiply it by 5. If you try to enter it all at once, you're going to have so many parentheses, it may not work out right. So 1 minus 8 to the 8th power is a pretty big negative number. I'm going to divide that by -7 for the denominator, and then I'm going to multiply it by 5. So if I were to write out the first 8 terms of the sequence, A1, A2, A3, A4, A5, A6, A7, A8, A8, and I were to add them all together, my answer for the sum of the first 8 terms is 1198375. Okay, these numbers are going to be very large because I am adding up all of these numbers, which are also being multiplied by 8 each time. So this is the correct answer for the first. Alright, let's do another partial sum. This time I want the first 25 terms. So I'm going to do S sub 25. I need to know, again, I'm going to write down the formula up here. You probably already have it, but S sub n will equal A sub 1, 1 minus r to the nth power over 1 minus r. Okay, so my first term is 400. My r value, well, if it looks like I go 40 divided by 400, and that's going to give me an r value of 1/10. In other words, I'm dividing by 10. And that's going to be 1 minus 1/10 to the 25th power divided by 1 minus 1/10. Okay, you have the option of turning that 1/10 into a decimal. However, if it's a repeating decimal, you really have to use the fraction. Because 1/10 as a decimal is a pretty nice number, it's just 0.1, you can definitely use that as you type it in. You're going to have to make the best judgment call. If you choose the wrong route, like you just do 0.3 instead of 3 repeating for a third, you're going to get the wrong answer. So make a wise choice. So I'm going to type this in as 1 minus parentheses 1 divided by 10 caret 25. Hit enter. Divided by, and you'll have to open another set of parentheses, 1, hit enter. We'll write that down, hit enter. 1 minus 1 divided by 10, hit enter. And then finally we will multiply by 400. So that's how I'm going to do it. Okay, so it comes out as 444.4 repeating. I went ahead and turned it into a fraction, and my fraction is 4,000 over 9, and that is me adding together the first 25 terms of this particular sequence. Okay, so the next thing we're going to look at is infinite sums, and infinite sums only work in a certain situation. My R value must be, so I'm going to have the absolute value of my R must be less than 1. Okay, but it also has to be greater than 0. So, well, no, I guess if I use my absolute value, sorry, let me get rid of that for us. So I'm going to be using the absolute value has to be less than 1. Now, I don't want to use the words it has to be a fraction, because 10 over 3 is a fraction, but it's not less than 1. 7 over 2 is a fraction, but it's not less than 1. So I am not going to use the words it's a fraction. I'm going to say that the absolute value is less than 1. And that includes your positives and your negatives, okay? All right, so let's go ahead then. And let's start by identifying our R value. So I'm going to take negative 1/9 and I'm going to divide it by 1/3 very carefully. And I'm going to come up with my R value to be a negative 1/3. Perfect. It's less than 1. Its absolute value is less than 1. That means I can find an infinite sum. So I'm summing these terms all the way to the last term we could possibly come up with the most powerful computer. I'm going to keep adding them together. So S sub infinity, or just S is how it's often written, just S, is going to be the first term. And this time I'm going to put a 1 over 1 minus the R value. So the only thing that's different here is my numerator, if you notice. So in infinite sum, the numerator is 1, but the denominator is still 1 minus R. All right, carefully go ahead and multiply that out in your calculator. 1 divided by, open parentheses for the denominator, 1 plus 1/3 you may use, and then multiply that times another 1/3 using parentheses. So if I were to add up all of these terms, they actually come to 0.25. That's it, or you may write that as a fraction 1/4. And that's kind of unique to think that all of this is actually adding up to 1/4. And we'll talk more about why that might be. Let's go ahead and try 2 more together. Okay, number 4. So we're going to identify, I'm going to write our formula. S is going to equal, and without anything written down here, it's assumed that's an infinite sum, A1 times 1 over 1 minus R. Okay, so I'm going to do 16 divided by 128, or 4 divided by 16, and 1 divided by 4. And I notice that they actually are all the same, and the common ratio is 1/4. Perfect. I needed that type of fraction, that less than 1, in order to make this work. So if I'm going to do that, I'm going to start with 128, 1 over 1 minus 1/4. So I'm going to do the fraction part first, 1 divided by parentheses 1 minus 1/4, and then I'm going to multiply that times 128. Turn it into a fraction, and I should have 512 over 3. Next, negative 6 divided by 2, 18 divided by negative 6. These all reduce to negative 3, which means I cannot do an infinite sum. So I would write not possible because R is greater than 1. That's your reason. Make sure you tell me why you've chosen not to do this particular problem. To leave it blank won't give me a reason that you understand it. Telling me that R is greater than 1 explains. Okay, we got 2 examples for working backwards. So this time I'm going to give you a sequence, 2, 8, 32, 128. It is geometric. I see a multiplier in there. In fact, I can see that when I multiply this way, I'm going to be actually multiplying by 4. And I want to know how many terms are required to sum up to 174,762. So this tells me the result, and I want to know what the n value is. I don't know how many terms actually were needed to get that sum. So because this is a partial sum, And it's partial because I'm looking at times 4. So it couldn't have been an infinite sum. I'm going to start with my partial sum formula, which is S sub n equals the first times 1 minus r to the n power over 1 minus r. Now if I look at that, I think, well, I have 3 variables. I have a1, I have r, and I have n. Well, the only thing I don't have is n, so we can solve for that. So I'm going to say 174,762 is going to be equal to 2 parentheses 1 minus 4 to the n power over 1 minus 4. And this is going to take a couple steps for us to solve. The first thing you want to do is divide both sides by 2. And that gives me 87,381 equal to 1 minus 4 to the n power over 1 minus 4. Well, what I notice is my denominator is negative 3. So I'm going to multiply both sides times negative 3. It's still in my calculator, so now I've got negative 262,143 equal to 1 minus 4 to the n power. Okay, so next I want to subtract 1 to the other side, and that gives me negative 262,144 equal to negative 4 to the n power. All right, I'm going to divide both sides by negative 1 so that it's positive, and that leaves me with 262,144 equal to 4 to the nth power. Now, I need to figure out what number I'm going to use when I say 4 to this power gets me that very large number. And to do this, I'm imagining you grunting after I say this, we're going to be using logs. You have to remember one simple thing. This is the base. Log base 4 of this big number will equal your exponent. It's the only log formula you're going to need right now. You have to know how to do it. I'm hearing you grunt, I understand. Okay, so that's my base. It goes in the bottom. The way this gets typed in the calculator, unless you have the new operating system that allows you to type it just like this, if you do, go ahead. If you don't, the number the base part, the 4, goes in the bottom. So it's log 262,144 divided by the log of the base, which is the bottom. Type that in using parentheses when you finish the numerator, and you will have an n value. Please note your n needs to be a whole number. It cannot be a decimal. I came up with n equals 9. To check your work, I would go back up and I would say 4 to the 9th power does equal 262,144. So it's the 9 terms are needed to make this value our sum. All right, let's go ahead to one more. We're going to use the same idea here. First, I want to go ahead and find my r value here, and I see that the r value is going to be 5. I'm going to use my sum formula, so 73242,186 equals the first term, 1 minus 5 to what power divided by 1 minus 5. We're going to go through these steps a little bit faster. You need to be very careful that you've written this number down correctly and that you type it in the calculator accurately. I'm going to divide by 6. I'm going to multiply both sides by negative 4. I'm going to subtract 1 to the other side so that my negative 5 to the n is alone. I get negative 48828 0.825 equals negative 5n. I know that I can divide both sides by a negative 1, leaving me a positive value, so 4,882,8125 will equal 5 to the nth power. At this point, I'm now going to be using logs. Log base 5, base because the exponent here has a base of 5, of 4,882,8125 equals n. To type this in the calculator, if you're using the old operating system like myself, that goes in the top and the base goes in the bottom. Carefully type that in the calculator. And you come up with n equals 11. So it takes 11 terms to acquire the sum of 73,242,186. All right, we did a lot in this video. Please go back and watch anything you need to, or use this as you work through the worksheet when we're in class together next.